Welcome back as we travel through the solar system. You've seen part one, how manned space travel got started. You've seen our solar system all the way to Mars, and now we're going to explore the 4 outer planets. Are you ready? Here we go. Jupiter is pretty amazing, if I say so myself. It has over 59 natural satellites. It is the largest planet. It has a very strong magnetic field, which helps protect the inner planets, protects the Earth. More than half is an ocean of liquid hydrogen. We think of the 4 outer planets as being gaseous giants, which kind of is true, because if we think of hydrogen on Earth, it is, of course, in gaseous form, or oxygen, or helium. But when we reach the extreme temperatures of the 4 outer planets, they're no longer in that state. If it was just 80 times bigger, we would be living in a 2-star solar system. Maybe we aren't much different than Luke Skywalker. Because Jupiter has lots of hydrogen and lots of helium, it would ignite. And it would actually be the 2nd star in our solar system. Let's go through the 4 Galilean satellites really quickly. First, we have Io, which is the most geologically active in our solar system. The circular objects are volcanoes, not impact craters. So it has one of the newer surfaces, a very young surface, because it's continually being renewed and remade. Why is it so hot? If you can imagine, you have Jupiter, which is huge, and you have 58 other natural satellites right beside you. That causes friction. Europa is also a natural satellite of Jupiter. It has a thick ice crust, and scientists believe that if we go 200 kilometers deep, we will find salty liquid water. Is this the best chance for life in our solar system? Maybe. The 3rd Galilean satellite is Ganymede. It is the largest satellite in our solar system. Pretty cool. And then the 4th Galilean satellite is Callisto. Of course, these 4 natural satellites were discovered by Galileo. Callisto has the most cratered surface in our solar system. And it's about the size of Mercury, a planet. That's pretty big. How do we know all this? Because Juno. In Greek and Roman mythology, Jupiter drew a veil of clouds around himself to hide his mischievous ways. And it was Jupiter's wife, the goddess Juno, who was able to peer through the clouds and reveal Jupiter's true nature. Pretty cool name for a satellite, especially one that's studying Jupiter. It launched on August 5th, 2011, and it arrived at Jupiter in 2016. That's not that long ago. Saturn. Saturn's pretty cool, and it has lots of natural satellites as well. And of course, it's famous for its rings because they're visible with binoculars from planet Earth. Awesome. And I've been able to see its rings. Pretty cool. But what makes it more cool is that we are so lucky to see the rings because they are slowly disappearing. They have been there for about 100 million years, and they only have about 100 million more years left. That's kind of crazy that we are here during this time to be able to see them. So go see them if you haven't. Its density is lower than water. That means if I can find an ocean big enough to fit Saturn and I threw it in there, it would float. Weird. We know this information because of a robot called Cassini-Huygens. It was launched in 1997 and it arrived in 2004. The grand finale of the spacecraft's final orbit, we went ahead and we sent it into Saturn's atmosphere, ending its extraordinary 20-year mission of discovery. And it brought back some amazing pictures of Saturn. And these are some pictures that Cassini-Huygens took. That one is of one of the natural satellites of Saturn. Okay, boiling points. Now, this is going to give you a lot of information about what it looks like at the 4 outer planets. Of course, you know about the periodic table of elements. It's like when I go into my cupboard to find the ingredients that I need to make lasagna. Well, when I look at the periodic table of elements, that's all the ingredients that I need to make anything on Earth, to make any planet, to make any star. Now, each of those elements has states of matter. So if we look at oxygen, its boiling point is negative 183 degrees Celsius. Nitrogen, negative 196 degrees Celsius. So when it gets to that point, it's going to boil and turn into a gas. So nitrogen is in liquid form past Saturn because the temperatures are so low, so cold, or absence of heat. On Ganymede, oxygen will rain on the surface. It's just different in these 4 outer planets than what we see on Earth, which is really, 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 really cool to think about. So if I look at the surface of the outer planets, I see things that look like rivers and deltas. But it's just not the way that we see them on Earth. We know that liquid water doesn't create these rivers. Maybe it's liquid oxygen or liquid methane. It just looks a little bit different, and we just have to wrap our heads around that. Uranus, King George. Why do I have King George on there? Because William Herschel, who was the British astronomer that actually named Uranus, wanted to name it after his king, which was King George. And the scientific community said, nope, you got to stay with our tradition. And so Uranus got its name. It has lots of natural satellites as well. It's famous for its tilt because it's sideways. It lays on its side. It has a beautiful green color due to methane, which is blue, and ammonia, which is yellow, atmosphere. Blue and yellow make green, so it has a little bit of a greenish tint. Yeah, Uranus. Maybe we should have named it King George. There's a beautiful picture of Uranus. Neptune. Neptune is our last planet. It has lots of natural satellites as well, and it's famous for its discovery because it was not by an observation but a calculation. We could tell that things were moving in the sky at certain points, and we were able to determine that, hey, something's there. And the scientists discovered Neptune. Its bright blue color is due to its methane atmosphere. Scientists were really surprised as we flew by Neptune. We thought it was just going to be dead and still and cold. I think that's what I would imagine as well, but it wasn't. It had an atmosphere, it had storms, it had volcanoes. It just wasn't liquid water that we were looking at. It wasn't the volcanic activity that we see on our planet, but the volcanic activity was due to methane. It's pretty awesome. We know this information about the 4 outer planets because of Voyager 1 and Voyager 2. They were both launched in the 70s, and their destinations were the 4 outer planets and beyond our solar system. So why is Pluto not a planet? Here is the definition. A planet is defined as a celestial body that A, is in orbit around the sun, B, has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium, nearly round shape, and C, has cleared the neighborhood around its orbital path. Well, yes, it is in orbit around the sun, or a star. It has sufficient mass for self-gravity to be round. It's round. And C, has it cleared its orbital path? That's the problem. Clyde Tombaugh, who discovered Pluto, did a pretty cool thing. So we had a robot called New Horizon, and it arrived in Pluto in 2015. Clyde Tombaugh's family actually gave ashes of Clyde Tombaugh to New Horizons, and it was on the spacecraft as it passed Pluto. So the person who discovered Pluto actually got to fly by it in 2015. Now, let's look at this carefully. Where Pluto is, which is the green orbit, we have Eris, if you look, is the red orbit. That was actually the planet that a scientist found and said, hey, we found our 10th planet. And then like the next week, another scientist said, hey, I found the 11th planet, 12th planet. And so that's why scientists had to get together and say, what is the definition of a planet? Otherwise, we're going to have thousands of planets. And so that's why you have to clear your orbital path. The Kuiper Belt, or the Trans-Neptunian Belt, is where Pluto and Eris reside. The hunt for planets outside of our solar system is something that scientists are working on each and every day, and they use a telescope called Kepler. Now, if you look in the Milky Way galaxy, you see our sun, and you see the yellow triangle next to our sun. That is where Kepler is searching for planets like ours, maybe that we can go to one day, that have liquid water. We are looking for that exoplanet that's in the Goldilocks spot. Just perfect amount of distance from the star to the planet so that liquid water could be a possibility. Now, what has Kepler found? Kepler has found almost 5,000 exoplanets. That's kind of crazy. And if we look at those planets out of the 5,000 that Kepler has already found, 30 of them are in habitable zones. Maybe we will go there one day. It's kind of cool to think about. This is Voyager 1. Voyager 1 is the robot that studied the 4 outer planets. And as it continued out of space, we told it to turn around and take one last picture of our planet. And there we are, suspended in a sunbeam, as Carl Sagan said. Isn't it cool that we are this pale dot that you can barely see from the outskirts of the solar system? It kind of puts things into perspective. Robert Goddard, the father of modern rocketry, said, "It is difficult to say what is impossible, for the dream of yesterday is the hope of today and the reality of tomorrow." I think that statement's really powerful. What are your dreams? And what will be the realities that you see in your lifetime? This is Orion, and this capsule is going to take men and women to the surface of Mars. That's pretty awesome. I can't wait to see the future. Thanks for joining me as we have traveled through the solar system. I hope you've enjoyed this adventure through space, and maybe a couple of you who are watching this video will actually be astronauts one day. That would be awesome! And you better hook me up.